it is time to start thinking about centralizing our player data and not spreading variables thinly across multiple blueprints. So what I'm talking about is that, for example, we calculating view distances and pickup ranges and stuff like that already in the project, placing them in the specific blueprint. So if I'm opening up the sports car, for example, we are here having a pickup range that we have hard coded to 200 centimeters. We need to centralize that, and perhaps the best initial place to do that, so we know where to look for it, is in a game instance. The game instance is created when your play session on your computer is created, so it's persistent across level loads and other ventures where the player might go inside the game. So that's a good place to store stuff. It's not the most perfect place in the end time of game making, but it's a good first stop. And by end time I mean when the game is done. You would probably want to have a more rigid system where you have save games and maybe C++ versions on where you save, and server-based stuff where you save your player info and the player progression. But the game instance is a good actor because it, as I said, it's persistent. So how to create it? You right click and choose blueprint class, and here we search for game instance. Game instance. Creating that one. So all sessions have already a version, a C++ version. We're just making a blueprint version of it. BP game instance. So having created that one, we need to hook it up to the game project, the same way as we did with the game mode. So at the same place, we are opening up the project settings. And in the project settings, we are clicking on maps and modes. And here we have the game mode and all our blueprinted versions that we made. And down here we have the game instance. And we just choose our version. As I said, it's a wrapper created around everything when the game session starts. So it's persistent. So this is yours, the player, each player hold their own game instance. And it looks like this. It looks like a completely normal blueprint, but you can't add it to a game world. It's a layer above it, and we need to save our player data here. We're gonna make a struct. A struct is basically a container that holds many different variables. So in player we create a new folder called data. That will be filled with all the nodes and hierarchies of the player. And in data, we right click and we choose blueprint, structure. And since it's a blueprint version, I want us to use the prefix of struct. In code, in C++, the coders use way more slimmer prefixes, but just for findability, when we script, it's good to have something to search for. And I find struct to be good. So struct player data. Struct player data. So opening this one up, this is, as I said, just a container for a number of different variables. So we could begin, this is the player data. We could begin by having a player name that we perhaps will use eventually, but not in this video. but we'll choose the variable of text. Text is letters and numbers that the player will see on screen. Then you should use this variable. And then we create another one. And this could be the view distance, because we use that view distance max. We can do view distance max. We could have different view distances depending on if we're in different scenarios. View distance max, and that should be a float. And adding another one, that could be the pickup range. Those two will be used in this video. Range. It's that bug. There we go. So those two will be used in this video, but just to showcase what the struct is and what we will use it for, I'm just gonna add health max, and this project can have another one called energy that the player can have as a value. It could be mana, it could be stamina, it could be anything. I'm just choosing to call it the energy. So here we just populate a number of different variables that will be the player's statistics, how fast it can he or she can run and crawl and everything. We could populate it here. But for now this is good. We will only use these two. View distance, I'm placing a big D there. View distance max. There we go. We can close this one down. We're going back into the game instance, and then we're choosing to add a new variable that we're naming player data, and that will be our newly created struct. So now I can search for struct, and we will clearly see the player data struct. Compiling it, and when we have compiled it, we can see here, we can see all our instances. So the name will be John Doe. It will be Tommy Norberg, obviously. View distance, we hard coded it a while back to 10,000, so we can keep it at 10,000. Pickup range, we have also hard coded it in a number of different blueprints to 200, so we can keep 200. The health max and the health energy, we could just set a very common value of 100. Compiling it. So this is just the holder, a persistent game session holder of the game data. So if we're moving to another level or killing the pawn or anything, we have it somewhere to retrieve it. So now we just need to retrieve it. So going into the player blueprints, the character blueprint player. So in the character blueprint, a lot of things is going on. Most of them are button presses, but here we also have when this specific pawn is possessed. So when this instance of the player is possessed, we do a lot of stuff. We add mapping, we do the crouching, and we initiate components. So this component is initiated here, and we give it a player camera reference. But we also, in this component, if we open this component up, it's located in blueprint components. Here we have it, the blueprint component look at. Here we have view distance, and we hard coded that one to 10,000. So we will not hard code that one. we will just add it from the player. So here we initiate it. We could actually add another one. And we will add both the view distance and the pickup range so that this look at component holds those two values. Clicking on this one, we're adding a new input value here. That is a float and view distance. And another one called pickup range. And then we can assign them. So that this is the view distance. We already have that one. So I'm just doing a set view distance here and assigning it to there. Currently we don't have anything, so if I'm compiling it, what's happening here, this custom event, we're feeding this custom event from the player, we're feeding it from here in the player. So now these have popped up here, so the view distance and pickup range. We're assigning it with 0, so it's currently broken, but let's just continue the thought process. We're making a variable inside here for the pickup range as well. Promote it to a variable. I'm right-clicking to get these reroute nodes. There we go. So let's populate these two variables, because right now they receive 0 from here. So we need to get the game instance. The game instance is always accessible. We can just write get game instance. This is the C++ version of the game instance. We created a blueprint version as a child for the C++, so we need to cast, we need to go upstream to search for a child, and we know that the child exists, but we still need to search for it so that the code knows. So we're doing a cast to BP game instance. So this is a child of the C++ version. So if it exists, it goes here. And we know it exists because we added it, but we still need to have a failed cast. And we can even, good practice is to make this, make a print string and do error, just writing game in, let's say did not find game instance, and marking it as a red text. So this will never, hopefully never ever show, but if it shows, then something went horribly wrong, and we can use this text to kind of like, then this text will pop up and we can start to realize that something is amiss. So this is good practice. Even though that we know it will never fail, it's good practice to do this. So now we have the game instance. Now we're reaching into the game instance and pulling out the player data. Get player data. And this is a struct, so we can split it. Break struct. So here we can see all the variables that we added to the struct. And these hold values. So we just add the view distance and the pickup range. Like so. So now we're starting to feed in our component, one of our components. We will add more components here so we can feed in all the other values. But now we're feeding it from one place. So we have the values stored in the game instance, and we're feeding all the other blueprints from one place, from the pawn. Centralized data flow, not spreading it out too much. So this receives here, and then we can give this information to any blueprint that is needing them. And who needs it? Well, if we are looking at the blueprint, here we're already sending the distance, but here we can also send the pickup range to the object. And why? Well, if we look at the sports car here, I'm going to the sports car. Here we're using a pickup range. We're looking at the sports car and we want to interact with it, and then we decide, are we allowed to interact with it? Are we within the pickup range? If so, then we should possess it. But if not, so this is the hard-coded value that we should try to stay away from. So how to get this? If we go into, this is the child. This is a child of the base vehicle. So going to the base vehicle, I'm clicking this pen here to auto update it. Event on looking at. So here, this is the communication node for communicating from the look at. So here we just need to pass the other value. And how did we pass it? This is an interface. So we just need to open the interface. And the interface is located in the framework interfaces. So here's this interface, the mailman, remember? Looking at, here's the look at. Distance to player, we're gonna pass along a new float that is interact range, we call it, right? Interact range. And compile and save. Now it's popped up here. Pickup range, I call it pickup range. God damn it. Interact range might actually be better because we might not pick everything up. It might be a button that we're pressing. So interact range is probably better. So let's do it. Pickup range. Renaming this one to interact range. And this one to interact range. And in the game instance, this is pickup range. That is actually the struct. So we need to go into the struct in itself. That is in player data. Opening up the struct, naming this one to interact range. There we go. And compiling and saving, we get interact range, saving the interact range, passing along. We're not passing along the interact range. Let's do that. So this is the value that we need to pass to the object that we're looking at. So now we're looking at the sports car. We're having this value here. This needs to be now we're in the child. Let's go to the base vehicle, the root, the parent. So here's the interact range. Renaming that one to interact range and setting it. So now we're setting the interact range, that is 0, but it will become 200. And then we go into the sports car, saving as well. We have 0 in interact range, hooking it in there, but it should become 200. So let's see if it works. It worked. If I'm standing here, Nothing happens. Nothing. Worked. Nice. Okay, so we have centralized the data. Something broke with... I'm disregarding that bug. That's for later. So we have centralized the data flow into a game instance, and we can begin populating correct values to our player, and we will continue that in the next episode. So take care, live long, prosper.